Okay, so I'm going to be talking about CK-powered auctions, more specifically how they apply to lending and borrowing. And the reason for this is essentially that fixed rate lending and borrowing is quite literally the backbone of the modern economy, but it's not present on DeFi yet. And it shouldn't be that way. Essentially, there are some projects that are already trying to do this with varying degrees of success. One example of which is Stern Finance, which does actually use auctions to sort of power this fixed rate lending and borrowing. The problem is that their full on-chain implementation is just not scalable. Running an auction mechanism on chain is very, very expensive. Having to do so for every order that was placed, you quickly run out of gas. And well, evidently that's where CK comes in. Now, CK for auctions is very interesting because it lends itself very, very well for this use case. Whereas in CK rollups, a transaction is not final until you settle a proof. Auctions have a predefined finality date. So on the finality date, you generate a single proof, which verifies the execution of the whole auction, and that's it. By moving most computation of chain, most state of chain, you save up tremendously, and you effectively are able to infinitely scale auctions. Now let's look into how this works. Essentially, users just place orders on chain by locking some money up. And instead of the order actually being stored on chain, what you store is a commitment in the form of a hash chain. So the way this is done is that, well, this hash chain essentially just encodes the entire history of the orders that were placed on chain. Now, this model of auction is called a blind auction, by which first users place their orders, and then they reveal the price that they specify. Again, we just update this hash chain, which just encodes the entire order history. And then we just settle a single proof, which clears the auction. The result of the proof, the output, is just the root of a lean incremental Merkle tree. And inside of there, we just have the allocations. The money that Alice got, the money that Bob's got, the protocol fees, anything we want. So actually, let's just focus a little bit more on what the auction proof actually does. We've taken as inputs the order history. With that order history, we're able to reconstruct this hash chain. So we know that we're not tampering with anything. We're not censoring anybody. The orders are as they were placed on chain. And then because this is borrowing, there's a collateral that's put up against it, right? We need to make sure that a borrow order is properly collateralized. For that, we query the on-chain oracle price. So effectively, one of the public inputs to our proof is the on-chain oracle price. Now, what this means is that if we're not able to prove faster than the oracle updates, our protocol can be effectively frozen. Now, we'll see that that's not really a problem, but yeah, then we just do the auction logic. We output everything inside of the exit tree there. So now let's talk some benchmarks. This is just very, very rough estimates because it depends a lot on the number of orders that you're clearing, whether sort of orders are fully filled or just partially or not at all. But what's important is that in all of these test cases, proving time stays consistently below 5 minutes. Given our constraint in terms of the Oracle update frequency, this should be more than okay for the vast majority of use cases. But really, the actual interesting benchmarks is just the gas savings that you get. You can see here, just to place a bid, just by moving from a fully on-chain approach to a CK powered one, you get that famed 10x cost reduction there. Same thing, kind of similar when revealing bids. Now, it's important that these costs, this 3 to 10x cost reduction, those are directly incurred by users, which means that it makes the protocol more attractive to interact with, right? And then the cost to actually settle the auction is greatly reduced as well. In fact, it is fixed. Before it used to scale with a number of orders. Now we are able to effectively fix it. By doing so, we can lower protocol fees, which again makes interacting with the protocol much more attractive as well. And that's pretty much it. You can find the link to the repo there or the original proposal if you're interested. Thank you.